Right, good day and welcome. I'm Mr. Simons. This lesson we're revising now slowly but surely how to draw a parabola given a standard quadratic equation, right? So, for parabola given f of x, which represents y, equal x squared minus 5x plus 6. To plot any function, we generally will find their x and y intercepts. So for x-intercept, it will always be y equal to 0. For y-intercept, x equal to 0. So if y is 0 there, in place of f of x, I put 0. X squared minus 5x plus 6 stays the same. Now we have to factorize factors of 6 that add up to minus 5. The last term is positive and the middle term is negative. The signs are always negative and negative. X squared is simply x times x, which gives me x squared. The factors of 6 that add up to 5, negative 3 times negative 2 gives me positive 6, but minus 3x minus 2x would give me minus 5x. Therefore, x equals 3 or x equals 2. If I take the 3 over, I take the 2 over, so my coordinate x is 3 and y is 0, x is 2 and y is 0. For y-intercept, x equal to 0. So in the place of x there, we place 0. 0 squared, 0 plus 6 gives me 6. So my y-intercept is 0 and 6. Right, now for all parabolas have a turning point. So to get the turning point given a quadratic equation, we have to determine first the axis of symmetry and then the y value to get the turning point. So for axis of symmetry, x equal minus b over 2a. So a there is 1, b is minus 5, and c is 6. So they go alphabetically, a, b, and c. So minus b, minus the 5. So it's negative times negative, which gives me positive 5. For a is 1, the invisible 1 in front of x squared, 2 times 1. So my turning point or axis of symmetry is 5 over 2. If you want to, you can go write it as 2.5. Right, this value will be substituted back into the equation to get the y value. So I have f 5 over 2 equal 5 over 2 squared in the place of x minus 5 times 5 over 2 plus 6. 5 times 5 gives me 25. 2 times 2, 4. Negative times positive stays negative. 5 times 5 becomes 25 over 2 plus 6. Now you can add them on your calculator and get the answer. I've just done it without a calculator. That's how I was taught at school. So 25 over 4 minus, there to make it 4, I'm going to multiply by 2 top and bottom. So 25 times 2 gives me 50. 2 times 2 gives me 4. There 6 times 4 gives me 24. And the bottom 1 times 4 becomes 4. So if I say 50 minus 25 gives me 25. Or negative 25 plus 24 gives me negative 1 over 4. So my turning point, graph all parabolas, as I say, must have a turning point, is 5 over 2 and negative a quarter. Right? So once we have the x, y-intercept and the turning point, we are able to plot the function. So next question, can we plot the quadratic function? So 3 and 0, they have plot 3 and 0. 2 and 0, they have plotted 2 and 0. 0 and 6 is the y-intercept, so thereby 0 and 6. My turning point in between 2.5 and negative a quarter, and I join them all up, and I plot through them, right? There, take note, that line in green, 5 over 2 is the axis of symmetry. The axis of symmetry ensure that the right-hand side looks like the left-hand side if we cut the graph there. Right, we must also know what's domain and range. So next question, 1.4, determine the domain and range of f of x. So if we continue plotting this graph on both sides, it's going to touch all the x values from negative infinity to positive infinity. So x is an element of real numbers. For range, graph turns by negative a quarter, and from there it's going up. Therefore, y greater or equal to negative a quarter. So from there it goes up. Right, let's look at the second problem. Alright, so in problem number 2, given f of x equal x squared plus 6x plus 8, Again, we will first find the x and y-intercept. And I say x-intercept y equal to 0 always, y-intercept x equal to 0. So if I make y 0 there, equal x squared plus 6x plus 8. Factors of 8, that adds up to 6. 4 times 2 gives me 8. 4 plus 2 gives me 6. And x squared is simply x times x. So x there, if I take plus 4 over, becomes x equal negative 4. If I take plus 2 over, x equal negative 2. So my x-intercept minus 4, and y is 0, minus 2, and y is 0. For y-intercept, x equals 0, so in the place of x, I place 0. At 0 squared is 0, 6 times 0 is 0, so I'm left with 8. My y-intercept is 0 and 8. Number 2, say when we have x and y-intercepts, we can't plot a parabola without a turning point. So there determine the axis of symmetry and the turning point given that equation. So for axis of symmetry, x equal minus b over 2a. b being plus 6, a being 1. So there we have negative times positive 6, and then 2 times 1. So negative 6 divided by 2 would give me negative 3. That negative 3 must go back in the equation to get the y value of the turning point. So that becomes minus 3 squared plus 6 times minus 3 plus 8. Gives me 9. Minus 18 plus 8. So minus 18 plus 8 gives me minus 10 plus 9 gives me minus 1. So my turning point is minus 3 and minus 1. So once I have the turning point, and I have my x-intercept and y-intercept, I can plot the graph. So we plot the graph there. We have minus 4 and 0, minus 2 and 0. We have a turning point by minus 3 and minus 1. And there where it goes up, it's going to touch the y-axis at 0 and 8. So hope you follow. So there minus 2 and 0, minus 4 and 0, axis of symmetry, minus 3, minus 1. And as I said there, if I can extend, that would be 0 and 8. Alright, domain and range. So domain is going to touch all my x values. If I continue plotting, continue there, so therefore I just say x element of real numbers, or we can say x element open bracket negative infinity semicolon positive infinity close, or not closed, open bracket at the end. Right, so there, that is just parabola given your quadratic equation. Hope you follow, hope you understand. Please like, share and subscribe.